Hello everyone, I am Dr. Pragya Sharma, Assistant Professor in the Department of Health and Human Performance. Today I am presenting my research on the acute effects of circuit training and traditional resistance exercise on sclerostin in young adults. Evidence suggests that physical activity promotes bone health through mechanical loading and biochemical signaling between bone and muscle tissues. A class of signaling molecules called exerkines play a crucial role in mediating bone-muscle crosstalk. As we know that exercise provides a myriad of health benefits by modulating osteokines. However, the underlying mechanisms of the acute effects of exercise training on sclerostin is still unclear. Sclerostin are the negative modulator of WNT signaling pathway. With increasing level of sclerostin, further leads to increase in bone resorption and increase osteosarcopenia and osteoporosis. Therefore, this study compared the acute serum sclerostin responses to circuit training and traditional resistance exercise in young healthy adults. In this randomized repeated measure crossover study, 12 participants, including 6 men and 6 women, completed the protocols across 4 visits. Participants performed 2 protocols separated by 2-week wash-out period, comprised of circuit training that includes the cycle ergometer, push-up, steps up, medicine balls, and front squats with kettlebell for 3 sets, and the traditional resistance exercise comprised of 3 sets, 10 reps, 80% of 1 RM for leg press, seated cable row, barbell bench press, kettlebell deadlifts, and dumbbell seated shoulder press. Blood samples were analyzed before exercise training, immediate post-exercise, and 30-minute post-exercise for sclerostin using enzyme-linked immunosorbent assays. Sclerostin levels were measured in duplicates, and we found the inter and intra-assay CVs below 15% for all the tests. Data were analyzed using 2x3 repeated measure ANOVA, and we looked at the significant interactions using a Bone-Forney test, and the level of significance was set at p less than 0.05. The results showed that there was a significant protocol time sex time point interaction for sclerostin levels. In male, sclerostin levels increased from pre to IP under both training protocols, and in both protocols, sclerostin levels decreased from IP to 30p. In female, sclerostin levels increased from pre to IP under both training protocols. And we also found that sclerostin levels decreased from IP to 30p. The results suggest that the acute exercise training induces transient increases in circulating sclerostin in both male and females, followed by a rapid decline during recovery, which supports that osteokines are regulated by mechanical loading and markers of bone's mechanosensitive response to exercise. Thank you.